Okay, let's discuss time value of money. And by that I mean, suppose you are given $100 right now, and you want to know whether a year from now it will still be worth $100. So you might be inclined to say, yeah, I mean, $100 is $100. If you look at a banknote, $100 now is the same as $100 in the future. What's the difference? And while intuitively maybe that makes sense, in truth it is not. It's not the same. $100 now is not the same as $100 in the future, for multiple reasons. One is the fact that inflation exists, and we'll talk about inflation in a future video. But the other is the fact that you can actually take the $100 that I'm giving you right now and invest it. And now we're flipping the table. You're no longer the one who's borrowing the money and has to pay money to some lender. At this point, you are collecting the interest on the money that you have. So now the interest goes to you. So if you were to invest $100 now, a year from today, it will presumably increase in value because you can collect some interest on it, which is pretty cool. So that type of analysis is that of the time value of money. And it is very important when discussing earnings, and corporate structures do this all the time, and many people do this for their own personal finance, in the sense that you want to know the power of your money. And in order for you to understand and to compare different sources of money, it is important for you to convert them all to the same time frame. And I'll go over a simple example in a second. You can think about that in the fact that let's say you make, I don't know, $100,000 today, and then you make another $100,000. You're gonna make a bunch of other money, in the interim. But let's say you make another $100,000 in 30 years. Okay, what happens in 60 years? Are they the same? Do you make $200,000 from both of them? I think it's pretty obvious to see that now you have more time to take the $100,000 and do something with it than 30 years from now. You only have 30 years to do something with it. And so in 60 years, the $100,000 from today will be worth more to you. So you can't simply compare the two and say they're the same. They're not the same. In magnitude, they are the same, but the fact that you can invest the money from today for longer means that you can make it work for you for longer and make more money off of it. I think if we look at a simple example, this will kind of make sense. Let's say we'll do some sort of very simple interest type of analysis. Let's say I'm going to give you a bunch of money at the end of each month. Okay, and again, it's pretend. I'm not going to give you a bunch of money at the end of each month. So at month 0, let's say I give you $100. So right now, this is month 0. I give you $100 up front. Okay, again, I won't. Sorry. And at the end of month 1, I also give you $100, and month 2, I also give you $100, and let's do it for 3 months. Okay, no freeloaders here. So I have this. So I want to know, as what I'm telling you is basically I cannot compare these values because I can invest this for longer than I can invest this. So in 3 months' time, what's going to happen? This is going to be worth more than this. So you might say, oh, Professor, I'm just going to add them up. At the end of 3 months, I have $400 from you. Yeah, well, technically, yes. But you also collect interest on the $100 you collect per month. So let's say you're going to throw this into some interest-bearing account. And for simplicity's sake, we'll say that the interest rate in this pretend scheme is $1 per month. For whatever reason. You get a $1 per month, that's my interest scheme. Okay? So it's not proportional to the amount of money that you put in. Well, obviously it's wrong. Obviously it's related to the amount of money that you have in there. But I want to do something just to illustrate this point. That means that at the end of 3 months, the interest I collected on this should be $3, because every month I make $1. At the end of 3 months, I can only invest this for 2 months, so I only made $2 on it. And the money that you get in 2 months' time, you can only invest for 1 month, so it will actually only get $1. and the money that you get at the end of 3 months doesn't have time to be invested. I'm comparing it at the moment you're getting this money, so you can't actually do anything with it. So this gets $0. And so what happens is that at the end, I can actually add them up, and I make 103, 102, 101, and $100. And basically, instead of $400, I make $406 on this imaginary scheme. And you can't see this because my head's in the way. But yes, so it's $406 instead of the $400 that you would intuitively think that it would be worth. And that has to do with the fact that you make money on this investment. So when we discuss taking a present value of money and converting it to some sort of future value, which is what we just did, this is what we call compounding. We just compounded it. When I go backwards, when I go from a future value, which I can do, and we'll do that right now, I can go from a future value backwards into a present value, and that is known as discounting. Now, why is that interesting? Well, I can see basically how much my money will be is worth at the moment, whether or not I have it. So going back to that hypothetical example of the $100,000 that you get today and in 30 years' time, well, the $100,000 that you get in 30 years' time, you can hypothetically say, well, it's kind of worth maybe 75 now, and if I were to invest 75 now, then in 30 years it'll become 100. You can kind of do that. And that will be comparable to whatever this money is, to the $100,000 you actually get today. You can actually compare the two and see what they mean for you in a hypothetical scenario. So if I look at this example again, right, I can do discounting as well. I can say, so instead of looking at the, it's the same idea. I still get $1 per month. Now, instead of comparing them all at the end of 3 months, let's do it at the end of 0 months. So obviously, I didn't get this money yet, or this, but I can kind of hypothetically understand what that money would be worth if I were to be given it up front. So this is still $100. I did not make money off of it. I just gave you a $100 note. So obviously, you can't make money off of it. You have it in your hand. You haven't made money off of it yet. This $100 will actually be worth $99 today. Because in a month's time, this will get an extra $1 and it'll be $100. This will be worth $98 and this will be worth $97. So I can compare the four at any time frame I want. I could do it at 0 months, 1 month, 2 months, 3 years from now, whatever it is. But in order for me to meaningfully compare them, I have to convert them to the correct time frame that I want, and I have to be consistent. Okay, and in order for me to do that, we will basically use the same idea as the compound interest that we had before, right? And so for me to get my buying power of my capital, right, I will need to just use this formula. This is in order for me to discount. I will apply this formula, and you can look at the previous video for the definition of these variables. The only thing I did not discuss is FV, and that is future value. So this is discounting. And if I'm doing compounding, I need to solve my future value, and that will be equal to P times 1 plus I over n to the nth power. Okay? And basically, again, this is future value, compounding, discounting. This is the amount of money that you are investing at whatever time frame you have. And this is the future value it will accrue based on this interest scheme, right? Where I would be the interest rate, which is a fraction again, and n is the number of payments that you'll be not number of payments, number of occurrences where you make money off this interest, and then n is the frequency that you're getting interest. It's just as last time, okay? And just for the completion's sake, let me just write that down for us. So P here would be my principal, which is basically my present value or my past value. Oh, behind my head it says past, present / past value. I would be the infraction, so less than 1, the interest rate. Okay, N is the frequency at which interest is paid, and capital N, which is equal to N times T, where T is time, and that is equal to the number of interest payments. So I encourage you, if you're confused by this, to rewatch the interest video where we discuss what these mean more intimately. But I mean, it's fairly simple. The only trick that we have here is to make sure that little I and little n are the same time unit. So often you say that the interest is given to you monthly, and this is usually given in a year. So you could say, I don't know, 10% per year, and you could say that it's being applied monthly. You have to convert one or the other. You always have to convert one or the other because they're incompatible. But basically, we will carry this analysis, and we can see how much money is worth for a company at the end of each time frame.